Super tornadoes, when the sky turns against us. Imagine standing on the open plains, watching thunderclouds tower above like dark mountains. The air feels heavy, charged with electricity. Then, out of the swirling chaos, a monstrous funnel stretches toward the ground. Within seconds, the horizon is swallowed by a force so powerful it can rip houses from their foundations and scatter debris for miles. This is not just a tornado. This is a super tornado, a storm at the peak of nature's fury, the birth of a monster. Most tornadoes emerge from thunderstorms, but only a special kind of storm, called a supercell, can spawn the giants. Inside these supercells, strong wind currents twist in different directions at different altitudes. This creates horizontal tubes of rotating air, which, when tilted upward by strong updrafts, transform into vertical whirlwinds known as mesocyclones. As warm, moist air rises rapidly and collides with cooler, drier air aloft, the mesocyclone tightens. Like a figure skater pulling in their arms, the spin accelerates. Eventually, a funnel cloud forms. If it touches the ground, it becomes a tornado. In the rare case of a super tornado, this process magnifies beyond imagination, producing storms wider than a city and winds exceeding 300 miles per hour. Beyond ordinary destruction, the scale of destruction from a super tornado defies belief. Entire forests can be flattened, asphalt can be ripped from highways, and steel beams can be bent like twigs. Some tornadoes are so strong they leave behind ground scars visible from space, wounds carved into the earth itself. The enhanced Fujita scale, EF scale, measures tornado strength, with EF5 being the maximum category. EF5 tornadoes generate winds over 200 miles per hour, but super tornadoes often surpass even that threshold. In fact, some storms have been powerful enough to carry debris more than 200 miles away from where it originated. Legends of the sky. History is marked by infamous storms that reshaped entire regions. The tri-state tornado of March 18, 1925, remains the deadliest in U.S. history. Cutting across Missouri, Illinois, and Indiana, it killed nearly 700 people and leveled whole towns in its 219-mile path. Survivors described a roaring wall of darkness moving faster than a train, obliterating everything in sight. Decades later, in May 2011, the city of Joplin, Missouri, faced one of the most destructive tornadoes of modern times. With winds topping 200 miles per hour, it killed 158 people and caused billions in damage. Hospitals, schools, and entire neighborhoods vanished in minutes. The scale of loss was so overwhelming that Joplin became a symbol of both tragedy and resilience. The science of survival. Meteorologists have made enormous strides in understanding and predicting tornadoes. Doppler radar, capable of detecting wind rotation within storms, has revolutionized early warning systems. In the past, people often had little or no notice before a tornado struck. Today, warnings can give 10 to 20 minutes of precious lead time, sometimes the difference between life and death. But challenges remain. Tornadoes can change direction suddenly, intensify in seconds, or vanish without warning. Predicting where a tornado will form or how strong it will become is still an unsolved puzzle. That's why preparedness is critical. Communities in tornado-prone regions hold regular drills, build underground shelters, and encourage families to keep emergency kits with essentials like water, food, flashlights, and medical supplies. Even knowing simple safety rules, such as moving to the lowest floor and away from windows, can save lives. Storm chasers and science frontiers. To unlock tornado secrets, storm chasers take daring risks. They drive specialized vehicles with reinforced armor directly into storms, deploying instruments that record wind speeds, pressure changes, and temperature shifts. Some even launch drones into the funnels to capture data never seen before. This information feeds into computer simulations, allowing scientists to recreate the birth of a tornado virtually. These models help us understand not just how tornadoes form, but how climate change might influence their frequency and intensity in the future. Warmer, moister air could potentially fuel stronger storms, raising urgent questions for communities in tornado-prone regions. Life after the storm. When a super tornado finally dissipates, its destruction is only the beginning. Survivors often return to landscapes that feel alien, streets they once knew reduced to piles of rubble, landmarks gone, and silence where entire neighborhoods once stood. Yet, amidst this devastation, the resilience of the human spirit shines. Volunteers rush in from across the country. Neighbors help one another clear debris, share supplies, and rebuild. Many survivors describe the storm as both the worst and most unifying experience of their lives. Out of tragedy, communities find strength, courage, and determination to rise again. Looking to the future, technology continues to evolve. Improved radar networks, mobile alert systems, and even experimental tornado drones promise faster warnings. Architects and engineers are designing stronger, more tornado-resistant buildings, while governments push for stricter safety codes in high-risk areas. Public education campaigns are ensuring that more people know how to act when sirens sound. Though humanity cannot stop super tornadoes, we are learning to coexist with them, to respect their power, prepare for their arrival, and recover when they pass. The final truth. Super tornadoes remind us of a humbling reality. Earth's atmosphere is capable of unleashing unimaginable power with little warning. They are both a scientific mystery and a natural marvel, terrifying, awe-inspiring, and unforgettable. By studying them, preparing for them, and remembering the lessons of the past, we can give ourselves the best chance to face the storms of the future. Because while the sky may turn against us, human resilience, knowledge, and unity are forces that even the strongest winds cannot destroy.